we live?
We're live now.
Okay.
Are we live? They were the days, weren't they? Are we live?
Are we live?
Good evening and welcome to another Fortean Words. I've done the titles. I can't hear Hobbit.
Science is great. Science is
Yeah, I missed the obvious title, didn't I? Isn't science amazing?
Isn't science amazing? Scientists have actually confirmed that science is big gay. Confirmed by science.
Well, you know,
You can read
hookers.
in,
We're not far off that, to be honest.
What do hookers, scientists, and politicians all have in common?
They don't like to be wrong.
they all
steal
have
your
a price.
Yeah, they don't like to be told they're wrong. I don't know.
They steal your money and promise you the world for it.
Mm.
Fucking long.
You don't pay them to stay; you pay them to go away. Anyway, so you two got this all covered. So where are we starting then?
Well, I thought we could start with a very important subject, which is close to my heart at the moment, and my esophagus.
Yeah.
What is the name for the meals of the day? And why do they call lunch dinner time? Because what I'm eating right now is my dinner.
Debate.
Also, is breakfast a verb? I would argue it is, because you're breaking your fast. You're breakfasting.
What are breakfast's pronouns?
Sausage, eggs.
Bubble and squeak.
Right. So. I restarted it. Okay. Right, so where are we starting off today then, boys? I was gonna...
Well, hang on.
Are we...
We've still got half an hour to allocate to the subject.
Alright, okay. Well...
We'll do it later.
We'll do it later.
We'll just let that one let that one breathe throughout the episode.
Yeah.
So which one of you two want to take this away then? Science and how much we all love it.
I guess I will.
Ether is real. Quantum mechanics is not. Coming to my TED talk now. Go away.
Right. Okay. So, as the name implies of the episode, we're going to do a deep dive into how we got to quantum.
Brian Cox on the BBC.
Yeah. Basically the chronological timeline of how we got to stupidity in the modern world of what were you talking about earlier, Hobbit? Tachyon something or other thing with 3 different flavors, strawberry tachyons, ones and that shit. Yeah.
Strawberry chocolate and vanilla.
I wasn't looking at tachyons, I was looking at neutrinos.
That's it.
Because I was saying like list of things which aren't real. List of things which. So I'll get into how miasma theory is like. There are things which aren't really understood. Like miasma theory has been replaced with germ theory for how you get infections, but I don't really want to touch on that subject. However, miasma theory gets you a lot of the way there. So we got concepts like gravity and neutrinos and bullshit like that which isn't real, but at the same time, it gets us probably 90% of the way there. Like, we understand this as attractive force which keeps us stuck to the Earth.
Does it? Does it, Hobbit? Is there a force attracting you to the Earth right now?
Yes.
Can you feel it, Hobbit? Can you feel
Yes. Yes, I can. I can demonstrate this, you see, by jumping, and when I jump, I go back to the ground.
Right. But Hobbit, are you not jumping in a liquid or a, you know?
Oh, actually, I've got an article from the BBC which might be pertinent. Right. So, this is called "Something's Wrong with Gravity." A new theory could rewrite the laws of physics as we know them and finally explain what... Oh, no. And finally explain what dark matter is. Oh, no.
Oh, God. We're there already. Jesus.
Scientific riddles don't come much more baffling than this. Entire galaxies seem to be in the grip of something that affects their behaviour, but no one knows what this something is. Well, we do. If it's a form of matter, then it must be the most abundant matter in the cosmos. Yet all attempts to...
See, there they are. This is it. They're just dark matter has just replaced the ether now. This is Einstein's ether.
Yeah.
Well, what we're talking about today is the ether, right? Yeah, basically.
So do you want me to finish it? Do you want me to finish this off?
Yeah.
We can kind of springboard from this. So if it's a form of matter, then it must be the most abundant matter in the cosmos. Yet all attempts to get a sample of it have failed. Not even the Large Hadron Collider can see a glimpse of it. Do you remember that BBC News thing? Banner that said the Large Hadron Collider. It remains as enigmatic as its name, dark matter. Now, one theorist has provoked controversy with a devastatingly simple explanation for why dark matter still hasn't been found. Oh, it doesn't exist. But that's not the only reason. Professor Eric Verlinde of the University of Amsterdam. Oh, it's Hobbit's favourite people again. Hobbit, are we throwing this in the bin now? Are we?
I'm not saying the Dutch are scum, but carry on.
It's attracting so much attention. After all, others have previously suggested dark matter may be some kind of illusion. What sets Verlinde apart is that it is explanation for the source of the illusion. He believes it's a result of nothing less than a fundamental misconception about the most familiar force in the universe, gravity. It's a claim that brings Verlinde up against the work of some against the greatest minds in science, including Albert Einstein. Albert Einstein, whose celebrated theory of gravity. Did Albert Einstein have a theory of gravity? I thought his was...
Well, yeah,
relativity. Okay.
Yeah, which is basically gravity. Like, and why gravity only, affects certain things,
It's one of the cornerstones of modern physics. Known as general relativity, it has led to a host of triumphs, including the detection in 2015 of gravitational waves, ripples in the fabric of space-time caused by the collision of two black holes. So the truth about gravity. Verlinde has spent years piecing together clues from theory and observation to create a whole new vision of the force we call gravity. Now his ideas are being put to the test with intriguing results. And at the centre of them all is the mystery of dark matter. Verlinde has been... It sounds like Belinda, but it's Verlinde? Verlinde? I don't know. He's foreign. Has been hailed as the intellectual successor to Einstein in the media. Yet he sees his goal in more down-to-earth terms. I'm just trying to explain where gravity comes from, he says. What, like there's a big gravity bucket somewhere? That might seem a bizarre statement coming a century after Einstein showed that gravity is the result of matter warping space and time around it. Yet, according to Verlinde, this overlooks...
Einstein didn't do any experiments. He didn't prove shit. Einstein just made up a bunch of sums in his head and said, "There you go. That explains the world around us." And then other people farted in applause, going, "Oh, you're so clever. Please, why don't you go and marry your first cousin after divorcing your first wife, which was your sister or something? If you're so smart, why are you marrying your first cousin, Albert Einstein, PhD?"
To keep the
Let me just take a minute to truly shit on Albert Einstein.
Hold on, let's finish this first, and then we can poop on
No, I hate Albert Einstein, and I hate him, and I want other people to understand what a fucking fraud he is. Anne Frank is more real than Albert Einstein, PhD.
It leaves unanswered the key question of exactly how matter expects space and affects space and time. To carry out his research, Verlinder has had to grapple with some of the deepest problems in science, including the quest for the so-called theory of everything, a theory that unites gravity with quantum mechanics that has been like. But the thing is, though, you can't have gravity set apart. So they're actually saying that everything has its own theory.
Mm-hmm.
Okay.
One of the difficult things about this is because we're not allowed to talk about the ether and not allowed to do proper research into the way things are, it means that a lot of the research into quantum mechanics, which is trying to ascertain the nature of the ether, it's just like the experiments aren't going the right way because they're not focused in the right. Imagine, like, again, the miasma theory. You know bad smells have got something to do with it, but you suspect that bad smells are not the be-all and end-all of infection, that there may be an underlying cause.
Yeah, but the thing is,
Hobby,
you can't mix up your theory of smells with your theory of rotting meat, can you? You've got to keep the two theories separate.
Well, that's what I'm saying. Miasma theory gets you 90% of the way there. So quantum mechanics, which is, by the way, a lot of schizophrenia from those that wear the small hats, it's close, but there's so much schizobabble, it's actually probably doing more harm than good.
So theorists have long known that general relativity cannot be the last word about gravity. That's because it fails to incorporate the other cornerstone of modern physics, made-up theory. As well as describing the subatomic world with astonishing precision, quantum theory has been able to account for all the fundamental forces of nature apart from one, gravity. Since the 1950s, theorists have tried to marry the two views of nature to produce one overarching theory. The problem, says Verlind, is that they are based on such radically different views of reality. For example, general relativity presumes that it's possible to pin down precisely where particles are and how they're moving, while quantum theory shows that's impossible, so taking gravity into account gives us a bit of a problem, explains Verlind. That sounds like bollocks to me.
No shit.
Yeah. It's like, yeah. Yeah, but the problem is like, how are we supposed to make shit up if you're telling us that particles are in particular places? For years, he worked on superstring theory, which many believe to be the most promising way of overcoming these problems. Yet, despite decades of effort and a host of mind-boggling ideas, there's still no hard evidence that it works. This has led Verlind down a different path in search for the truth about gravity. The origins of this truth lie in a series of surprising connections between gravity and an apparently unrelated part of science, thermodynamics, the physics of heat.
Oh no, really? That's interesting. The laws of thermodynamics. How many does quantum mechanics break there?
Thermodynamics is real, bro. Trust me.
Well, I mean, the laws of thermodynamics, like, yeah.
Hey, why don't you go and read a white paper? Oh, I don't know, because they're all locked behind a $100 member wall. Thanks, Pergamon Press, owned by Robert Maxwell.
In the early 1970s, theories studying black holes, notorious for the intensity of their gravity, discovered they must also be packed with something called entropy. Remember, donate to my entropy. Widely used to understand the behaviour of hot objects. Entropy reflects the number of ways rearranging the constituents of objects without changing their appearance. Calculations showed that black holes contain the highest possible entropy that can be crammed into a given volume of space. Nobody tell Mark Collett that. But they also revealed something else. Common sense. Something else. Common sense suggests that it depends on the constituents of objects. The entropy of a black hole should depend on its volume. Yet theorists found it depends only on the hole's surface area. Yeah, they don't. Yeah, they haven't found.
There's the 4-hour essays talking about the morality of Thanos' finger snap.
Yeah,
I'm not saying this. Yeah. This is fantasy. But also, it kind of is.
Yeah, they don't know about black holes because they haven't even fucking been near one. It's like it might just be some dirt on the radar screen again, mightn't it?
I don't know. Have you ever been to Birmingham? That's a pretty black hole.
Oh.
Stranger still, the calculations suggest the black hole's surface is made up of a vast patchwork of so-called wank areas.
Calculations show.
Suggest. Calculation. No, they don't show it. They suggest it, Fraser.
Oh, it's not even showing. It's suggesting. So a bunch of numbers suggest something, right?
Yeah.
There's a certain rule to live by. You know, maths is not reality. Like maths.
Oh, is this what someone? I think. Is this what someone said earlier about weight isn't real or something?
Just before we get into that, we've had the definitive statement by Barry Stanton, a scientist. Evolution is a load of codswallop, can trace my family tree back centuries, and at no point was any of them a bloody monkey.
Good old Barry Stanton.
Right, lad.
Named after the eponymous German pioneer of quantum theory, Planck areas are far smaller than even than a subatomic particle and appear to be the building blocks of space. Is it me, or are they just thrown in these $5 words to try and make stuff make sense? It's like
I used to love when science was about experimentation.
Yeah, you had to do if you take yourself back to college, you had to have your what was it called? Oh fuck! You had your what was it called? You started with your hypothesis, didn't you? And then you proved whether it was true or not with science. Yeah, with the scientific method. Yeah.
You got your Bunsen burner. You fucking cook the toad and cut it open, and you know. Then
let's remind ourselves of the. Let's remind ourselves of the scientific method for those kids who are brought up in new days where you just make shit up.
Yeah. Yeah.
See, it's horrific. It's literally white supremacy.
Literally worse than Hitler. This, yeah.
Scientific method. So there's an ongoing so the ongoing process. You know, not the settled science. The ongoing process.
Yes.
Hold on, let me just get this up on the screen.
Yes. In science, you should never say, "Oh, it's proven." You know, that's not science.
Yeah, science is settled.
That's a religion when it's proved. When you say you prove something, you
right. So, observation question, research topic area, hypothesis, test with experiment, analyze data, report conclusions, observation question, and you start again. So that's the scientific method. And that's the way the scientific method should work. When you're not being paid by the Daily Mail to write stories about wine.
So, how have we observed... What was the things called? Smaller than subatomic particles? What are they called again?
Yeah.
How have we experimented with these things? How do you even know they're there?
Well, why are we even pissing around with the subatomic level when we haven't got the atomic level fucking squared away yet?
Has anyone seen an atom? Anyone in chat, hand up if you've seen an atom. Anyone?
They're really real, guys.
Yeah.
What's the smallest you've able to see, like with the human eye, right? Or even some micro, telescope. It's never gone to the atomic level. We've got. Oh, you say we've got an electron microscope, but that's never actually proven atoms. It's just proven an effect. That's all they found, an effect, and therefore atoms must exist, right?
Right, but you're a scientist. Let me read this paragraph out and tell me if you think it makes sense. So, pondering these mind-bending connections between the physics of heat and space-time, Verlind began to wonder if they were hints of a radical new way of thinking about gravity. Heat was once thought to be a fundamental property of matter that exists in and of itself, like electric charge, for example.
Yes.
But now
thermodynamics.
But it's now known to ultimately be the result of collisions between the millions of atoms and molecules that make up a gas, liquid or solid. The faster the atoms and molecules that make up a material move, the more energy they have and the hotter the material appears. Thus heat is actually an emergent property. So what do you think to that then?
So the heat emerges from the collision of atoms rubbing against one another.
Yeah.
Mm-hmm. In an object, yeah.
So if you
Isn't it strange, like when atoms move, like the more they move, the hotter it feels?
Yeah, the friction, isn't it? The friction of the atoms. Yeah. I've chucked it in the back chat if you want to follow along with us.
Strange to think that fire is essentially friction, and it's the sort of friction like if you burn a log or something, the friction will rub it off until you end up with ashes.
I thought, isn't it excited molecules though, heat?
Well, I'm using the analogy of friction. Like, the more you rub something, the hotter it gets. So with fire, it's like it's rubbing, and then the fire's rubbing the fuel, and it's turning it into more fire.
Okay.
So it's a self-sustaining reaction until the fuel runs out.
The question he's not asking is what makes atoms and molecules move faster or slower, isn't it?
So like the more energy they got, the faster they can move around.
Yeah.
But you have to put energy into them. So like the heat. So do you think the heat is an emergent property then, Hyatt?
Well, that would break the law of thermodynamics if the thing can create more heat than the energy you put into it.
So by emergent property, they're saying like the heat emerges as a byproduct of the energy being released.
Yeah.
Or energy being transferred.
You can read it yourself. It's just above Newton and Einstein. So, because sometimes things make sense when you read them yourself, don't they? So it's
where is this Einstein rings? Oh no, I've saw that last week.
Back chat.
Yeah.
Science Focus.
Yeah, well, Einstein rings was last week, wasn't it? Because I got annoyed with that.
Oh, did you? We ain't got down to there
yet. Yeah, remember reading about it, and then I said, who's the author of this? And it was Rossana Ruggeri. It's like, hello, I'm a proper scientist, I am.
No.
Then a belly button, and oh, look, this woman has got prominent abdominal muscles. It's like, yes, well, women have abdominal muscles too.
Right at the bottom, Hobbit, last thing I'll put in.
Something's wrong with gravity.
Yes. So it's the paragraph above Newton and Einstein as a header.
Okay. So, my mind bending to physics, heat and space time, simply wonder whether hints of radical new thing about gravity. Here's one sort of fundamental problem about existing of itself like electric charge. I want to be the result of collisions between the moon's atoms.
Alphabet Cast says, if only all scientists were like Walter White in Breaking Bad, that's the kind we like to see.
The faster the atoms and molecules, well, most of them are actually. A lot of them are just psychopaths who just go, hey, this could be dangerous and kill people. Cool, let's try it out. The faster the atoms and molecules make material move, the more energy they have.
Wasn't the original definition of atom a really small piece of cheese? What is Alderaan?
No, atom, the etymology of it is an ancient Egyptian god, Atom.
Atom, yeah.
And he's like, is he the god of small things? I don't know.
Atem, wasn't it?
The god of tiny penis. Huh. You got tiny penis. So therefore, because heat comes out of it, so could the supposedly fundamental force of gravity also be emergent? Its real origins being linked to entropy and those incredibly tiny Planck areas of space-time.
Stop the press. I've got an amazing joke, right? This will certainly get your theories of heat and entropy and gravity all mixed up. How do you make fire with two sticks? This is very pertinent to the conversation we just had.
Rub them together.
No, actually, make sure one of them is a match.
I don't cringe.
So
that joke gave me COVID.
Isn't it amazing that heat's a bit like gravity?
What does that mean? Like, if I jump up in the air, I'll cool down? Because like jumping up and down makes me hot.
Well, I think what he's trying to say is that, like, okay, so everything, it's emergent, and there's, you know, gravity is not like comes from all things, then, is it?
Well, what holds molecules together?
I don't know.
Is that gravity?
Heat rises just like gravity.
Well,
Yeah.
what? I don't know. Yeah.
What holds shit together? Now that is a question that needs to be asked.
Oh, I know the answer. Gluons.
Gluons.
That's a clever particle name. Gluons.
Yeah.
Oh yeah, I got to tell you guys about neutrinos later because this is like I'll take shit that's not real for 500, please.
In 2010, Verlinde created a stir among theorists when he not even at least they're not calling them scientists. When he published a paper showing how his theory could be used to accurately derive both Newton's and Einstein's laws of gravitation. The similarities with other known. Go on then. Do you want to read some of it?
Oh no, I was just covering you whilst you were snoring.
You're yawning.
Yawning.
Snoring,
yawning, same difference.
Similarities with other known emergent phenomena, such as thermodynamics, have been mostly regarded as just suggestive analogies. Ooh, suggestive. Declared Verlinde. It is time we not only notice the analogy and talk about the similarity, but finally do away with gravity as a fundamental force. Just throw it out. Just throw it out the window.
Just chuck it out. Wait, if you chuck gravity
falling down the stairs.
What happens to gravity if you chuck it out a window?
Does it fall down or does it go up?
Yeah.
It's just like falling down the stairs.
Yeah, just like it. While intriguing, many theorists remained unconvinced the finding was anything more than a quirk of physics or just made up bullshit like the rest of them.
Hold on. Wait, what is a quirk of physics?
I have no idea. That isn't interesting.
What is a quirk?
Hey, look.
We can't explain it. Well, you know.
You're not following the rules of what we've made up.
Yeah.
Mm-hmm. You know, it's one of those amusing little personality quirks, like, I can't explain this, tee-hee-hee. I'm so cute, I am.
Ooh. Verlinde needed to come up with something that didn't merely reproduce existing theories, but predicted something new and testable. Well, at least this dude's moving in the right way. He wants to find something testable.
Right.
Yeah, one point for the Dutchman. He now believes
no, don't get too excited. Read on.
Oh, right. He now believes he's found it with the enigma of... Oh, no. Now he's let himself down with the enigma of dark matter. Is this what you meant of it? Or does it get worse?
Well, that's it. You know, it's just like, oh, guys, I'm going to test this and prove it's totally real. Yes, I'm going to discover dark matter. It's like, oh, okay, then.
Isn't that what the large hell portal is supposed to find? While hints of his existence emerged over 80 years ago in studies of clusters of galaxies. Like, they haven't even fucking been... We haven't gone past the fucking moon. Like, how's existence emerged? It's got to be some sort of...
Hints! No, hints! It's a hint of it. It's
hint of existence.
So, it's a... Well, hint.
Oh, I fucking love science. I flipping love science, I do. It was discovery of a curious...
It just feels like a continuation of that last episode when we were talking about gravitational rings.
Yeah.
Yeah. And I mean...
Were we talking about rings around Uranus, Hobbit?
No, around galaxies.
It was discovery of a curious effect inside galaxies that first convinced astronomers to take dark matter seriously. But even then, it's like, so how does long range astronomy work? Because obviously you haven't got a lens big enough, and you can't like zoom in far enough.
So
it's like interpreted matter, isn't it?
Because you use radio waves, big radar dishes.
Yeah, but how long does it? Yeah, but. How long does it take? Because radio waves, do they go faster or slower than the speed of light?
Speed of light. They're all going at the speed of light. It's just you can build these big radio wave receivers, and you can also build arrays of them. So it doesn't matter that you've got like one small dish, because if you get like 100 or 1,000 of those small dishes and combine together, it makes it like one massive dish. And you just like scan the radio waves and go, well, it's just helpful that stars emit radio waves, not just visible light. So you just use that because we can make radio telescopes that are far more sensitive than visual telescopes, and they're not subject to visual distortions of the atmosphere getting in the way. But because the atmosphere has like wind.
Well, that's why stars twinkle. That's why stars twinkle, don't they? Because the atmosphere.
Well, there's people that like zoom in on stars and say, "Well, look, these aren't stars; they're something else," because they're not just points of light. They ripple and stuff. It's like, yeah, because
climatic patterns, isn't it?
Well, because when you're dealing with that amount of air, it works like a fluid. And if you've ever looked at something through a swimming pool or something, it will distort rays of light. It's quite noticeable with water. But with air, because it's such a nebulous subject... sorry about the pun. Because it's such a nebulous subject...
I've got an even better one here. You can't trust atoms. They make up everything.
Yeah.
That's bad.
The thing about atoms as well is so much of it is like not real as well. It's like
well, it's like, isn't the atom supposed to be like the smallest matter? So why are we talking about the subatomic level?
Well, that's the thing. There are like fundamental particles which make up atoms. Atoms are just like one thing. But hey, another thing about that is the atoms themselves, when you actually get into them, there's nothing actually there to touch. You just deal with clouds of probability. So an electron microscope is an abstraction of these clouds of probability, saying like, well, look, something's probably here, and it will give you a fuzzy image of something that may or may not be there, which is just really just making a stream of electrons bend in a certain way.
So it's just interpreted data then?
The way to imagine it, right, is imagine like the nucleus of an atom is a 5p coin, and the empty space of that atom is like a big stadium, like Wembley Stadium, and the electrons like not even a grain of sand, like a dust mote, orbiting in the car park outside Wembley Stadium. Except don't even think of it as a particle of dust orbiting. It's better to think of it as like it's a cloud of probability. Like the dust particle's probably there in that square meter somewhere, but you can't say for sure. And if you observe it, it'll be at a single point, but then it'll collapse and then it will turn into neutrinos. So don't ever observe a electron directly. If you do, bad juju.
No, so it's a bit like
it's one of those like,
is it like a watch pot never boils, but slightly different?
Well, it's one of those let's just pretend this doesn't exist of the observer affecting the outcome. Really, what people should be saying is like, well, look, we found that there's this layer beneath the space-time matter constraint of our universe, which is consciousness, which is God's consciousness, and we can interact with this consciousness matrix and affect reality in the space-time continuum, because that is a lesser dimension which is contained within consciousness.
In Star Trek 5?
And you could call the conscious this matrix that all matter is contained within the ether, but we're not allowed to talk about the ether anymore. It's weird. Like even my granddad understood the ether, and he's like, there's no such thing as the ether. That's what they taught me in school. It's like, well, why did they go to efforts telling you that there's no such? Imagine I went into school and I said, right, guys, today's lesson, pay attention. You in the back, Jones, pay attention. Today we're going to learn about how unicorns aren't real. Why are we doing, sir? Yes. Why are we learning about things that aren't real? Shut up. Pay attention. No, as I was saying, unicorns and the ether aren't real, but we have this thing called quantum mechanics now.
You're not one of those unicorn believers, are you?
I do believe in... Hey, if unicorns weren't real, then why are they on the coat of arms of my country? Checkmate, atheist.
If unicorns aren't real, what's a narwhal? What's a narwhal horn?
Yeah. That's just a unicorn of the sea.
Yeah. Right then, according to where were we?
Well, hints of existence have emerged over 80 years ago in studies of clusters of galaxies. That's where we're at.
Yeah, it was the discovery of a curious effect inside galaxies that first convinced the astronomers to take dark matter seriously. According to Newton's law of gravity, stars further from the centre of a galaxy should orbit more slowly than those closer in. But during the 1970s, studies of stars within spiral galaxies showed that beyond a certain distance from the centre, this effect simply vanished. The most obvious explanation is that the stars were being affected by the gravity of an invisible cloud of matter surrounding the galaxies. It soon became clear that whatever this stuff was, it couldn't be made from the standard building blocks of matter. That sparked a global effort to detect a viable alternative, which continues to this day with no success. We've got a real top guy, top men, as Indiana Jones would say. This has led to growing suspicions that the most obvious explanation is simply wrong. In 1983, physicist Professor Mordechai Milgram of the Weizmann Institute in Israel pointed out a curious fact about the galactic evidence for dark matter. It can also be explained if Newton's law fails to accurately explain the motions of stars in the outer reaches of galaxies, feeling an acceleration due to gravity at this isn't even punctuated. So you're supposed to read this as, it can also be explained that if Newton's law fails to accurately explain the motions of stars in the outer reaches of galaxies feeling an acceleration due to gravity at a rate less than a certain critical value, around 100 billionth that generated by the Earth. So because they can't use punctuation, that sentence doesn't really make a lot of sense.
Look, they're scientists, not punctuationists.
Yeah, so I've been an anti-science person.
Yeah,
Mr.
Leave his grammar alone, eh?
I insist on having consistent grammar rules in my language. What I've learned.
I just like to not. I just like to not read about 4 lines of text in on one breath. Is that just too much to ask for?
It was going on in one long continuous sentence, going from topic to topic, very hypnotic. Captain Jean-Luc Picard of the USS Enterprise.
Oh, so this guy's going to totally shit on Newton and his laws of gravity. Right, okay.
No, not Mordecai Milgram. I don't believe Mordecai Milgram would do such a thing. While intrigued.
God of USS Enterprise. Make it so.
While intriguing, what Milgram called...
Hey, can we have that as the outro song?
If you can find it. What Milgram called modified Newtonian dynamics, or MOND, simply replaced one mystery with another. Where did this critical acceleration come from? That's what Verlinde decided to find out using his ideas of emergent gravity. I quickly found a back-of-the-envelope calculation that might explain it, but I had to work for a number of years to make this more precise, he says. Full stop and, Hobbit. Full stop and, they've written here.
Is this a BBC article? Right?
Yeah.
Or is this
and now believes he has succeeded. It's BBC Science Focus.
I really like it when people, start a sentence with "and."
Yeah.
Yes.
That's good science journalism. You can see that 110 IQs paying off dividends for this journalist.
What's good about science is the attention to detail, isn't it? That's what's great about science.
Yeah. I really like it when someone tells me about science, can't be bothered to write like science sentences scientifically. four line fucking single sentences and full stop and sentences. It's great, isn't it?
Mm-hmm.
The key lies in the effect of the entire universe on the vital ingredient needed for the existence of gravity, entropy. Donate to my entropy. According to both Newton and Einstein's theories, the donate to my entropy of objects like the black holes increases with their area, but Verlinde has shown things change on the scale of the whole universe because dark energy.
That don't matter. Now it's dark energy.
Dark energy. First identified in the 1990s. Theorized, maybe. Dark energy is a kind of anti-gravitational force. It's anti-gravitational. That is propelling the expansion of the universe. Its origins remain mysterious. Made up. But calculations by Verlinde show that dark energy leads to entropy, increasing with volume, not just area. That changes the behaviour of gravity at cosmic scales, and says Verlinde, the result is an acceleration effect, creating the illusion that dark matter exists. So, are we up with that?
It's an illusion! What are you hiding?
So So, what's he saying? Let's try and break this down. So, so dark energy is anti-gravitational, so therefore it throws stuff out.
Pushes away, right, rather than attracts, right?
Yeah.
That's what gravity is, right? So it's the opposite of that.
Its origins are made up, but calculations by Verlinde show that dark energy leads to entropy. So what did he say entropy was again? I can't remember.
It's what Mark Collett uses for his pay piggies.
Yeah. Entropy increasing with volume, not just area. Maybe Mark needs to get some dark energy in his entropy then. That changes the of gravity at cosmic scales, and says Verlinde the result is an acceleration effect creating the illusion that dark matter. So dark matter is an illusion, dark energy is real. Get excited for dark matter, get more excited for dark energy.
Okay. Yes. Thanos snap.
Thanos snap. What was that? In an expanding universe, the gravitational laws have to be adjusted at the acceleration scale indicated by Mond, he says. Unlike Mond, however, so Mond is the modified Newtonian dynamics.
Why would you have to modify it? Why do you explain to us why you need to modify it?
Because with this
it doesn't work.
Because with this imaginary idea, it doesn't work.
Ah, okay, right. I see.
Unlike Mond, however, he has been able to calculate the effect using basic physics. Verlinde's what's so funny phrase?
He can't calculate it using basic physics, therefore we have to.
No, he said he can.
No, he can't. However, he has been able to. Oh, wait, okay. Oh, yeah. I thought it was the other way around. Fuck.
So, unlike Mond, Mond is like some bodged up thing, but he's been able to calculate the effect using basic physics.
Oh, so what he's saying is basically, unlike the made up shit, he's actually used real physics and he's actually been able to test something, right?
It's almost like quantum physics are bullshit.
Yeah, it's almost.
Anyone would think, anyone conspiracy-minded would say that. Verlinde's theory does more than explain why dark matter has never been found. Astronomers have long been puzzled by a law linking the brightness of spiral galaxies to their spin rate. Known as the Tully-Fisher relation, it makes no sense... Tully, it just makes me think of Rick Moranis from Ghostbusters. The Tully-Fisher relation. It makes no sense using conventional theories of gravity, but Verlinde has shown that it's a natural consequence of the link between gravity and entropy. So this he's going all out for entropy, is his theory.
Yeah.
Further evidence backing Verlinde's theory comes from recent studies of the light from distant galaxies. Well, it's not actually the light from distant galaxies, it's the interpreted light from distant galaxies, isn't it, Albert?
Yeah.
So how do they get light from distant galaxies? They don't.
Don't you worry about it. Just give me more money to research dark matter. It's like, all you've done
dark
with this
matter. Dark matter. You some sort of Luddite or something. It's all about dark energy now, mate.
Dark energy.
Oh, what? You wearing flares? You're wearing flares with your dark matter, right?
Look, I couldn't do the grant for shark sleep science, so give me money so I can have a giant swimming pool, and we're going to use this to study dark energy because neutrinos are going to go into it. Yeah.
Dark matter. According to Einstein, the gravity field of galaxies can bend the path of light rays. This is known as the gravitational lens effect. An international team of astronomers has found that this effect is consistent with the prediction of Verlinde's theory without the need for dark matter. Go on then, Fraser.
I mean, okay, so bending of light, you haven't proven that. How do you prove that light can be bent? It can be refracted, but you're talking about bending it in its entirety, right? Around an object.
Well, they're saying that the gravity field of galaxies can bend the path of light rays. A bit like when you put a spoon under your tap.
That's what refraction is.
Yeah. Now the search is on for evidence that Verlinde's theory does not explain MOND, but outperforms it. And here some problems have emerged. Astronomer Dr. Federico Lelli and his colleagues at the European Southern Observatory have been studying the orbits of stars in galaxies, and they're not behaving as expected. Verlin's theory predicts a stronger gravitational pull than MOND in the inner regions, says Lelli, but this effect doesn't seem to exist. This seems to be a serious issue, he says. Although he probably goes, this seems to be a serious issue. It's a me, Mario. That's probably what he says. The biggest problem facing Verlind, however, is the explaining a cosmic coincidence. Why does it, or as Chris Pratt would do, it's me, Mario. Why does the amount of dark matter needed to...
mate, it's me.
It's me.
At least Bob Hoskins had a go at it.
It's me, Mario. It's a me. It's a me, Mario. Why does the amount of dark matter needed to why does the amount of dark matter needed to explain galaxy rotation curves match the amount needed to explain observations of the early universe? But no one's observed the early universe because it was fucking hundreds of years ago. The observational evidence for dark matter from a variety of methods is all... This just seems like competing versions of made-up stories.
That's why I'm saying this makes as much...
All based upon the premise from one singular point in time. We'll get to that. But yeah,
Alphabet Cat says dark matter is the sticking plaster of astrophysics, and 123 says dark matter is as real as the Dark Ages.
Yeah.
Aldarian says sea lions, sea cows, seahorses, but somehow a sea unicorn is a step too far.
The observational evidence for dark matter from...
Albert Ray says he's quite good. Dark matter is the scientific equivalent of in it.
In it, mate. The observational evidence for dark matter from a variety of methods is all amazingly consistent. Yeah, but, you know, dark matter's so last year. Says astrophysicist Professor Netta Bachal. Bachal? It's not Bachal, it's Bachal. Princeton Netta.
Bacho.
Netto.
I'm expecting poos in the street.
Or Netto.
Netta? You know, like Netto, but Netta.
Yeah, I'd like a cornetto.
Yeah. The simplest explanation is that dark matter really does exist, but it just hasn't been found yet. But Verlind points out that his work on the nature of gravity is far from complete. To explain these effects, one has to develop the theory to the point where one can describe the cosmological evolution of the universe, he says. I'm currently working on these ideas, but it will take quite some time. Given the huge payoff, if he's right, many scientists are willing to cut Verlind some slack. We're in a period when it's necessary to explore new ideas, says astronomer Professor Stacey McGaw of Case Western Reserve University, Ohio. At full start of sentence, and it takes a long time for such things to settle out. So that's from 2017, so I don't know what Verlind's up to now.
6 years ago.
Yeah, so I don't know what Verlind's up to now. He's probably sussed it by now.
Right, okay. And so where he says, what is it? What is she saying? Why are we needing to basically, you know, new ideas? Why is that? Why would that be the case?
Why would what be the case?
We're in a period of necessity. When it is a necessity to explore many new ideas.
Surely we're always in a period when it's necessary to explore new ideas.
Right. Okay. Is it because the ideas don't or are coming up against things that aren't?
Well, you know, they're
observable anymore.
Even with all their mathematical
Because
equations, they still haven't come up with dark matter, have they? Even though they can make everything up, like they're playing like science D&D, they still can't come up with dark matter, can they?
Well, this is it. They're all they are doing, and I'll get to the reason why I think they're doing this. Obviously, is they are trying to fit the theory. You know, fit the evidence to fit the theory, right?
Mm.
And they are not allowed. You know, they've been, again, like Hobbit said earlier, the path is split and they've been taken down this wild goose chase of, you know, it's got to be this and that, it's got to be all these different things, because they can't mention this one simple thing, which is the ether. This thing that had been for hundreds of years, you know, agreed upon by many scientists as like a
and Hobbit's granddad.
Yeah, and Hobbit's granddad, as a constant, you know, observable, you know, fundamental part of the makeup of our universe, our reality, right? And the problem is with the ether, a lord, I think it was a lord, Maxwell, he discovered the constant of light, right? He proposed the constant of light being 3 to the 10 to the power of 8, right? That is the constant of light. This is observable in, you know, even today. It's, you know, consider that speed. Hasn't changed. It's constant. But the problem is you've got a boatload of experiments in the late 1800s trying to disprove the ether, right? To disprove the ether. And why? Because having an ether actually points or even, you know, proves that the Earth is not the thing that is moving. It is the ether that is moving. Or no, not the ether that's moving. Is it the ether that's moving over us?
I
think it is.
Come on, I've teed it up
that's
for
a
you.
good question, you see, because now we have to have this, like, unfortunately, fundamental question. Are we on a rotating spheroid that orbits in a helical pattern around our sun, which in turn is going a million, billion, zillion miles an hour as it orbits around the galaxy, which in turn is going a zillion, million, billion miles an hour around space? And so I find it very interesting, like in the conventional physics model, right? You got the sun in the center, the planets orbit around it, but remember, all this time the sun is traveling, so the planets are kind of following it in a
is
cone.
It not driving, it's traveling.
Yeah, but despite this, Sirius, Polaris, all the other stars, all the other constellations, there is a procession of the zodiac signs, but they more or less, like, they stay in the same place. They don't get distorted. And surely at some point when it's like, well, if our star keeps traveling, what are all the other stars in the night sky traveling in the same place? And that's why it appears to be static.
Well, if we're going 1,000 miles an hour, why is it, you know, Orion's belt stays pretty much in the same place all night?
Yeah, but we're not. But we're only rotating that way. That's the Earth is moving 66,600 and something miles an hour, right?
Oh, well, that's when it orbits around the sun, and then you also have to take into account, like I said, the million, zillion, billion miles an hour, because the sun is also moving through the cosmos, and all of the planets which orbit it are being dragged along. That's why. Don't think of it as just like a flat disc with circles going around. Think of it more as like a cone or a spiral, and the planets follow it this way. So that's the conventional view of astrophysics. The anti-vaxxer, chud science denier view of is that the Earth is a stationary object at the center of the universe. The sun, the moon, the stars, and all the other planets orbit around it, and the ether travels through the stationary Earth.
And there were some experiments done, and I think we'll go over these because these are the things that led us to what we just read in that article. The reason why we have to invent dark matter, dark energy. And the first one I want to bring up is, we do Aries failure first. Yeah, let's do Aries failure. Fine. More Aries failure. No, that's bullshit. Oh, Aries.
Yes.
It's really interesting that Aries Failure does not have a Wikipedia page.
Airless failure?
Yeah.
What is that?
It is an experiment.
Oh yeah, that was sound quite interesting. I want to know more about that.
Yeah.
It's certainly better than the bullshit I was going to talk about with neutrinos.
Well,
I will talk about neutrinos, but
isn't science amazing?
Yeah, this is bizarre, right? It doesn't have a Wikipedia page. I wonder why.
Do you know the Cliff's Notes on it, Fraser?
I do. I basically, I'll read read off. Right. So.
Oh, cool. A diagram. I like these.
Right. So if you put that up on the thing, right? What?
Fresnel's coefficient. I'm not familiar with that.
Oh, Aries failure. Oh, there's a Aries failure. The Flat Earth wiki.
Yeah, don't. That's the society. I wouldn't touch that with a fucking barge pole. That's bullshit. Half of that's bullshit.
Geocentricity.
Yes. Well, that's basically it. Yeah.
You got
basically
that one,
Aries failure. Right. Okay. So from the image I've put up on screen, right. Basically, what Aries did was he had two volumes of canister. In which light would come into the telescope through a telescope. One was filled with water and one was filled with air, right? And he found that there was no difference in the light passing through the water or the air. There was no difference in the light, other than reflection. Okay, right, from the water, basically. So normal angle, yeah, that's it. Okay, so basically, yeah, he was direction of motion, and he moved these things along while the light was shining into these telescopes, and basically the experiment basically provided an example. He failed to prove that the Earth was in fact moving, because if the angle at which the light were coming in, it would be different if the Earth was moving, right? That's a basic from what I remember. Okay, I'll read this. Okay, so Airy's failure was an experiment in which George Airy failed to confirm the ether theory by measuring stellar aberration, which itself proved Earth's orbital motion, right? The ether hypothesis predicted the water-filled telescope should produce a different value of stellar aberration compared to the air-filled one. The change was not observed, hence Airy's failure. It helped in ruling out the ether theory. Stellar aberration is an annual shift of positions of stars. It was the first direct evidence of the Earth's motion around the Sun. Flat Earthers claim Airy's failure was about proving the Earth's motion. In reality, the aim was to confirm the ether theory, but it failed to do so. The experiment relied on already accepted knowledge that the Earth is in orbit around the Sun. Airy's failure was an experiment formed in 1871, in which Sir George Bidwell Airy failed to confirm the ether theory by measuring stellar aberration. Phenomenal stellar aberration itself was the first direct evidence of the Earth's motion around the Sun, supposedly. The flat earthers claim that Airy's failure is a failure of proving motion of the Earth, which it didn't. Didn't provide any evidence of that of the sort, because it didn't move. In reality, the experiment aimed to confirm the ether theory. Failure was in proving the ether theory was rallied around accepted knowledge that the Earth is orbit the Sun. The ether drag hypothesis predicted that the water-filled telescope should produce a different value of a stellar aberration compared to the air-filled one. The change was not observed, hence the name Airy's failure. The experiment helped ruling out the ether theory. Meanwhile, the phenomenon of stellar aberration is annual shift of apparent positions of stars. It was the first direct evidence of the Earth's rotation around the Sun, first observed in 1727 by James Bradley. Sir Avery himself, much aware of this fact, quite obviously, this is from his first paragraph of his publication. The subject to which attention is particularly called this is the effect that which will produce an apparent amount of angular displacement of a star or planet which is caused by the Earth's motion of translation known as the aberration of light. So yeah, basically he failed to prove that the Earth was well, flat earthers would say that he failed to prove the rotation of the Earth, yeah. But here he is claiming, or they're claiming, that Aries failed to prove that there was an ether, right? Okay. So next, from this, we had the Sagnac experiment. And this is another. Where did that go? Disappeared. We had a Sagnac experiment. Find that. Right, we could go on to the Michelson-Morley one. Have you got this, Hammy?
Yeah, you want to use that... hold on.
I've got the Wikipedia thing here.
No, geocentricity. Geocentricity seems quite a good website.
Yeah. Okay, right, okay. Aries failure reconsidered.
Put your link for it. So this note, very helpful, ambiguous escape hatch from an unthinkable truth, did, however, did not have a very long life. In 1887, Michelson and Morley's once and for all experiment to confirm the heliocentric creed turned out, as is well known, to be a dismal failure. Not only did it demonstrate an Earth virtually at rest in an omnipresent ether space, the outcome also served to entirely refute Fresnel's explanation of aberration. I can't find... They don't actually tell you what the Michelson and Morley experiment is in this.
Do they not? Do you want to use the Wikipedia then? I'll put it up in the back chat.
Go on then.
It's just a Wikipedia thing, but yeah. Right, so we got Michelson-Morley, right? Okay, so the Michelson-Morley experiment was an attempt to detect the existence of a luminiferous ether, a supposed medium permeating space that's thought to be carrier of light waves. The experiment was performed between April and July 1887 by American physicists Albert A. Michelson and Edward W. Morley at what is now Case Western University in Cleveland, Ohio, published in November of the same year. The experiment compared the speed of light in perpendicular directions and attempted to detect the relative motion of matter through the stationary luminiferous ether wind. The result was negative, in that Michelson and Morley found no significant difference between the speed of light in the direction of movement through the presumed ether and the speed of light at right angles. This result is generally considered to be the first strong evidence against the then prevalent ether theory, as well as in initiating a line of research that eventually led to special relativity, which rules out stationary ether of this experiment. Albert Einstein wrote, "If the Michelson-Morley experiment had not brought us into serious embarrassment, no one would have regarded the relativity theory as a halfway redemption." Oof. Michelson-Morley type experiments had been repeated many times, steadily increasing sensitivity of those included in instruments from 1902 to 1905. In a series of experiments in the 1920s, more recently in 2009, optical resonator experiments confirmed the absence of any ether wind at 10 to the minus 17 level. Together with the Ives, Sitwell and Kennedy Thorndike experiments, Michelson-Morley type experiments form one of the fundamental tests of special relativity. Okay, so detecting the ether. And do you want to continue with the thing? That's basically the experiment. It was to detect.
What's it? The Gedanken experiment? You know about this one?
No, I haven't. No. Ones I'm familiar with are Sagnac and this one and the Aries failure.
It's blimey. It's somebody who really loves herself, right? This one. They've really tried.
Hey, just out of curiosity, like it's sort of tangentially related to the subject, but
yeah.
You know the Northern Lights?
Yeah.
And there's also the Southern Lights, or the Aurora Australis.
Yeah.
The Aurora Australis, you could see it in Australia.
The Aurora Fairealis, more like.
Yes. The Aurora down under.
Yeah.
Well, in a flat Earth, what's causing the lights there then?
I don't know.
Because they say I saw one flat Earth model, and they say, well, there's a big hole in the North Pole. That's why people aren't allowed to sail there, and it's off limits. and through that hole you can see the black sun. And at night, the black sun shines up into the night sky, and that's the aurora borealis.
Couldn't there be two holes either end? That's what the North and South Poles really are.
Well, not if it's on a ephemeral.
Yeah, because if it's a flat Earth, then it's not
flat Earth. Yeah.
There's not a South Pole. It's just a wall.
Who knows?
Flat Earth.
No idea.
Flat Earth BTFO then.
I'm not like saying flat Earth BTFO, but also I'm saying flat Earth. Explain this.
Is it Donut Earth? Are we going back to Donut Earth, Hobbit?
Might be.
I quite like Hollow Earth.
How about Donut Earth? What's wrong with Donut Earth?
You still got the same problems on fucking Hollow Earth.
If we were on Donut Earth, would you not like look up in the night sky and then go, "Oh look, that's the other side of the world"? Yes, because our world's a donut.
Not if we're on top of the donut.
Yeah. But what about like, you know what? I'm going to go visit those people on the top, in the inside of the donut. Wouldn't they be like,
look up.
here I am in Japan, and I'm looking across at the other side of the world, and I can see Australia because it's a donut world.
Yeah.
I mean, that's one of the things, like the Iceland and Greenland tourism boards. Like, yes, come to our country and you can see these lights at night. I'm pretty sure that would be a big tourism pool. Like, oh look, I can see the other side of the world from here because it curves in on itself.
Because it's Donut Earth.
Did Big Globe kill the Franklin expedition, Hobbit? What is the Franklin expedition?
I don't know.
Right,
is that
okay?
So hence I first want to evaluate Aries data from an Earth at rest with sun and starry dome revolving with respect to us. Switching from the analogies to the reality, it will be seen that this theoretical position saves the appearances faultlessly. The speed of light taken to be constant throughout observable cosmos. The 20-inch 0.5 tilt of Aries water-filled telescope ruled out the Earth's motion. It revealed and confirmed that the stars of the stellatum all run their slightly elliptical courses with precisely the 30 kilometers a second velocity, still mistakenly attributed to Mother Gaia. She is on the pivot when the heavens turn. I'm fully aware with the mind of modern men will find it difficult, if not impossible, to accept this conclusion, as it makes havoc of everything the cosmogonists and the cosmologists have assured us of since childhood. Over against that, I can point to two solid considerations seldom realised. The so-called scientific method, now overwhelming us with more extra-mundane notions about black holes, cosmic strings, billions of light years, and whatnot, offers us nothing more than possibilities. True, to devise theories that are more or less cogently explain unreachable far-off phenomena is a game we can play ad infinitum, but affirms Stephen W. Hawking, any physical theory is always provisional, in the sense that it is only a hypothesis, you can never prove it. Or to quote another scientific eminence, Sir Arthur Stanley Eddington, 1882 to 1944, for the reader resolved to eschew theory and to admit only definite observational facts, all astronomical books are banned. There are no purely observational facts about the heavenly bodies. Astronomical measurements are, without exception, measurements of a phenomena occurring in a terrestrial observatory or station. It is only by theory they are translated into knowledge of a universe outside. So what's Copernicus' theory? That's the sun-centric, is it?
Copernican, that's us, heliocentrism.
Oh,
right?
was Copernicus we're the centre of the universe? Earth's the centre of the universe.
Yeah, geocentric. Yeah, geocentric. Yeah, that's right.
Yeah.
Then there's heliocentric. Yeah, geocentrism. Yeah.
So he says, to show this, let's return my Gedanken experiment, where we imagined an observer walking through the rain. The first circumstance with this view forced us to realise that the telescope must be tilted at such an angle that the raindrops remain untouched by it. So what he was saying earlier that I didn't read out is that basically it's an experiment where you try and let raindrops go straight through a tube. He said what you'd have to do is you'd have to tilt it forward.
On my head.
Tilt it forward slightly.
Yeah.
Raindrops are going through my tube. Or the photons can, after
science gets proof of rain.
After traversing the instrument and unimpededly proceeded in the direction they had before entering it, which is to say, for an unaided eye not clamped to the ocular but posited in the line of sight to the star, the telescope might well have just not been there. But for a man at the eyepiece, things are quite different. The trajectory of the ray emitted by the faraway point source, Gamma Draconis, may enter exactly at the objective, but it egresses obliquely to the plane of the ocular. That is, the star will not be seen by the astronomer manning the instrument. A line in your telescope with your line of sight is not the same as a line in your line of sight with your telescope. The first is easily done, the second is impossible. The stellar aberration 1A Bradley, I thought I said La Bradley, but it's 1A Bradley, has telescopically never been observed. In short, the convinced Copernican Boscovich proposed the right thing for the wrong reason. He supposed the water-filled telescope would conclusively prove the heliocentric theory, but to translate a Dutch expression, with that crooked stick, Airy made a straight hit. Do you like that one, Hobbit?
No.
Okay.
No.
His experiment...
Also, what's HMS Terror? That sounds pretty badass.
Yeah. His experiment was powerless to... HMS Terror... Is that... oh, shit, that's Shackleton, isn't it? Didn't they all eat each other or something? There's been a film about it, hasn't
there? Franklin Expedition.
Ah, they all ate it. I think they all ate each other or murdered each other or something. His experiment was powerless to show that Gamma Draconis circular movement was only apparent. Short-sightedly forgetting the fact that telescopes cannot bend radiation to look round corners, he affirmed on the contrary that stars really describe orbits equal to that of the sun. This is getting a bit boring now. Albert, can you read some of this?
I have to.
You can flick through it.
Where were you at?
Geocentricity VD Camp, is that the one? Michelson-Morley experiment.
That's the one, yeah.
Michelson-Morley experiment.
I'm quite a bit further down than that, but
this is some very
Wordy.
Audience,
Yeah.
are you captivated with this, or would you like to talk about dinners or neutrinos?
No, neutrinos. We need to talk about neutrinos now, anyway.
Well, okay. Let me get to the point I was making all this. Right. Okay. So Okay. We've got Michelson-Morley experiment. They fail to prove the. They come back with a null hypothesis, right? A null result, right? Basically saying that they could not detect any movement of said ether. But instead of coming to the conclusion we can't detect the movement of ether, therefore either the ether isn't moving or we are not moving, they decide that, oh, well, that just proves that the ether doesn't exist, because we already know that... yeah,
because I think they hinted at that in one of the bits I read out.
Is that not
that it wasn't a bust? It wasn't a bust.
Yeah.
They just proved that we weren't moving.
Yeah, it proves that we weren't moving, right? Yeah, but they unconscionably couldn't come to the other question was asked. Then, well, if we can't detect the movement of the ether, are we actually not moving ourselves then? But because obviously we've had 400 years of, well, we're living on the side of a ball stuck spinning in space, right? Because, everyone's, believes that, or, because the ancient Greeks, blah, 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 sticks in sand prove, the sun, whatever, we're moving, right, through space, right?
It doesn't prove that the sun is a close object that's, like, close to us, which would produce the same effect.
So basically, they rather than asking the question of, are we moving, they decide, well, we already know that's not true, therefore we don't need ether anymore. Basically, that was the conclusion they came to. Because the other one is unfathomable. That's why when they tout this as, oh, we proved the ether wrong, therefore, special relativity comes in and saves the day, right? But that's why special relativity was brought in. It was brought in then to build upon this null result, which, disproves the movement of the ether, and also subsequently begs the question of whether we're moving or not, to then shepherd in, well, we're now, everything's relative to each mass, in space. So therefore, that's how we ended up with fucking what Hobbit's going to talk about now, neutrinos and God knows what, right?
Neutrinos, amazing, right? So,
and that bullshit piece we just read earlier about fucking dark energy. Well, this is it. That's what I was saying. Like, they got rid of the ether, only for then now to have to come up with things that replace it, right? So they got rid of the ether.
Yeah, so they come up with dark energy, which seems to have a lot of the characteristics of the ether, don't they?
Yes, exactly. So now they're coming to the conclusion, oh well, we can't mention the ether because then that would have proven Einstein wrong and Michelson-Morley and all these other works, and it begged the question whether Earth is spinning, and we can't do that because we built industries on going to space and SpaceX and God knows what else, right?
It's definitely not money laundering, honest.
No, yeah, but it's basically can't admit. This is the problem with scientists. It's ego. They can't admit they're wrong. We've got to the point in science where it's about celebrity. It's all about
I think it's part of that. The other part is that back in the good old days, like proper scientists would have patrons. So people like Einstein, Newton. Well, probably not Einstein, but people like Newton and like the Galileo and those kind of people. They'd have rich patrons who'd pay for them, and they'd just let them do whatever they wanted. Whereas now scientists have to earn a living, and they have to earn a living by coming up with papers.
Even in the same place, like Galileo and that, they probably were
like the other bit.
They were paid.
Like the other bit of science,
I was going to
talk about the red wine. The red wine studies. Sometimes big red wine's paying the bill. Sometimes big white wine's paying the bill, and that depends whether red wine is good or bad this week, isn't it?
Yeah. Yeah. I mean, I was going to play that bit of the video at the end of that video earlier about the Michelson-Morley thing, and they literally just say like, oh yeah, because of we can't accept the fact that the Earth is stationary, therefore the ether must be removed.
Yeah.
And so we end up with what we have now is this, we're bringing ether back, but we're calling it something else because nothing seems to be working, guys. Our models don't seem to be panning out. That's why we're having to like add things on. Again, an ego thing. This is why we are in I Love Science, with fucking everything that we've got now, right? Shark study,
shark science. Yeah, we're going to prove sharks dream.
Yeah.
And end of study. Do sharks even sleep? Don't know.
Well, to be honest, at least they're doing something. At least they're up to be able to test something rather than these fucking pseudoscientists.
Yeah, we read them every week, don't we? The space episode where they just go, "Oh, we're doing made up shit."
Yeah. At least sharks are real. So, as bullshit as shark science is, at least you can say the guy is doing like proper science, even if it's bullshit proper science.
Yeah, it's
this is all just bloody mate. But seriously, like these scientists have got PhDs in advanced Marvel studies. They're talking about Thanos snaps, and that's why I want to talk about neutrinos.
Go on, Hobbit. Tell us all about neutrinos.
Neutrinos, amazing.
They're amazing.
There's a photo of them. What's in the back chat? If you want to stick it on the OBSC. Now, neutrinos, right? I'll describe this photo to the radio listeners.
What is this? Did a child draw this?
No, this is an actual real photograph of it. So we got these squiggly lines. Ignore them. Those are just the scientist's pubes. Now,
what is that?
We got labels on this. We got proton path, neutrino transformed into a
did his pants explode or something? Is that why curly
meson, and collision creates pi meson. Invisible neutrino collides with a proton. So we've got, protons in here. They
what am I looking at? What is this? November 1930.
This is a hydrogen bubble experiment. So you've got bubbles of hydrogen and an invisible neutrino, which is by the way, neutrinos are totally real, by the way. So this invisible neutrino, which is really
invisible neutrino. Okay.
It really hits this proton, which makes it go one way. The neutrino carries on another way. And then there's something called a pi meson, goes like the opposite direction of the proton.
Experiment.
Yes.
Yes.
So ignore the stray pubes. The scientists were just, having a bit of a laugh that day. So the funny thing is, whilst I was talking,
is this just a microscope on a toilet lid? I mean, you can see the outside of the toilet lid there, and that's the pan.
Yeah, exactly. That's it, isn't it? Yeah.
So I was talking with the guys about this before the show, and they just they've even got 3 flavors of neutrinos. But no, get this right. The actual official scientific terminology for the 3 flavors of neutrinos are 3 leptonic flavors. Now, what's a lepton, you ask? Good question. Anyway, moving on. So, a neutrino, which is pronounced neutrino, is denoted by the Greek letter V? Oh, nu, sorry. It's a fermion. What's a fermion, I hear you ask? Good question. Moving on. It's an elementary particle with a spin of 1/2. So a spin of 1/2. Right? Pay attention in the back now. It only interacts via the weak interaction and gravity. That's a good illustration.
Wait, whoa. The weak interaction. Why does
in nuclear physics and particle physics, the weak interaction, which is often called the weak force or weak nuclear force, is one of the 4 known fundamental interactions, with others being electromagnetism, the strong interaction, and gravitation. So I'm glad we cleared that up. Now,
do you have to move on quite quickly with a lot of neutrino science then, I bet?
Yeah, so neutrinos, they only interact via weak interactions and gravity. The neutrino is so named because it's electrically neutral and because its rest mass is so small.
So like Women's Institute orange juice when you go to a fete, like that kind of weak interaction.
Yeah.
Yes, it's homeopathic orange juice. This is a homeopathic particle.
You can't beat Women's Institute orange juice when you go to a jumble. There's only like 1 drop in it, isn't there?
Well, it literally proves homeopathy right. Like, the less they put in, yeah. So, the rest mass of the neutrino is much smaller than that. Is there ever a time when the particle's at rest? Good question. Anyway, moving on. The rest mass of the neutrino is much smaller than the other known elementary particles, excluding massless particles. Oh, well, I'm glad we solved that one then. Those massless particles. Now, what's a massless particle here, you ask? Well, it's a very good question. Anyway, moving on. Just keep on paying those science research grants, please. The weak force has a very short range. The gravitational interaction is extremely weak due to the very small mass of the neutrino. Oh, well, that's convenient. And neutrinos do not participate in the strong interaction. Oh, well, okay.
Is that because they look like pubes?
No, ignore the pubes. They've got nothing to do with neutrinos. Those are just errant pubes.
They're just on the seat.
No. Neutrinos do not participate in the strong interaction, thus neutrinos typically pass through normal matter unimpeded and undetected. Weak interactions create neutrinos with one of 3 electronic flavours: mango, pineapple, rum and cola. No, electron, muon and tau. I personally like rum and raisin.
How? Is that where they came from?
How?
No, the thing is, right, that you say, okay, so there's 3 distinct different types, like there's electron ones, there's muon ones, there's tau ones, right? But, except no, because, wow, I will explain that in more detail later on. I'm glad you asked that question. We won't move. No, we will move on to explain that.
Blimey.
Each flavour is associated with, oh, I'd really like some passion fruit sorbet. Why don't, like, this is a thing, right? Just as an aside, yeah. Why don't most supermarkets sell sorbet? I have to go to no, I went to Tesco's and they didn't sell it. Was it Co-op? They don't sell it in that. Aldi is shit for ice creams, by the way. Fuck you very much, Aldi. It's like, I don't want salted.
I got lemon sorbet from there.
Really? Oh, yeah. Maybe they're having the seasonal lemon sorbet. I'll have to check in.
Yeah,
there,
I saw some lemon. Like cookies and cream.
Like Aldi.
Aldi like to do flavours like ball sweat and caramel flavour and mint and cricket. I'm just.
Do you want caramel flavoured chocolate? Ah, fuck you! We've thrown some salt in it.
Yeah. Just dripping salt into the wounds. That is your chocolate consumption.
Were you looking for a nice sweet treat? Fuck you! We're throwing salt in there, you bastard.
Yeah, Aldi do the mochi ice creams, which are like £3 for one bite. I mean, it's like the penny lick, except it's the £4 penny lick. Oh, they actually no, they do. I can't believe it's not a Solero, and you get 3 in a pack for £3,
awesome.
Which is, well, it's a bit expensive, but anyway, each flavour is associated with. Oh, I'm getting thirsty reading this.
It's associated. Remember that article we did once, Hobbit? How to slow the poor bloke that's working at the till down in Aldi. I
got fucking angry with that. I wanted. Did I? I mean, I had to do community service after I paid a visit to that journalist, but it was worth it. I said to the judge, I said, look, oh shit, I can't say that on YouTube. Yeah. She called me a racial slur. And the judge says, right, I award you 10 hours community service, and you're doing 14 years hard labour, bitch. How dare you call him a racial slur?
Yeah.
And then the judge kicked her in the balls. And then everybody in the court clapped.
Yeah.
So they come in 3 flavours, right? Electron, Muon, and Towels. Although neutrinos were long believed to be massless... This is funny, right? It's long believed to be massless. It is now known that there are 3 discrete neutrino masses with different tiny values.
How is it known? How is it known? Because you can't observe them; they're not affected by anything.
How do you know it's got mass? Have you read it?
I'm glad you're asking these questions. They're very good questions.
Moving on.
So different tiny values. There's the reason I'm saying moving on to this one. The smallest of which could even be 0. Oh, there's a citation there. Boyle, Lathan, Finn, Cayman, Turok.
The monster hunt, dinosaur hunter.
So the monster hunter is now hunting for neutrinos. Yes.
Is that where he went?
He's hunting for neutrinos.
Wait, the dinosaurs didn't die out, they just became so small we can't see them anymore.
Just got shot with neutrino arrowheads.
Well, all of those dinosaur bones are radioactive. They've got neutrinos in them. Boyle, Latham, Finn, Kierman, Turok, Neil. 2022, The Big Bang, CPT, Neutrino Dark Matter, and also Physics 138. And then there's like some numbers I'm not reading out. So anyway, there's 3 discrete neutrino masses, right? But the smallest of which could even be 0. So I'm glad we're all following along, right? Don't worry, there'll be
Don't think about it. You're thinking about it. Don't think about it.
Now remember, class, unicorns aren't real. Now moving on to these neutrinos, some of which mass could be 0, but they definitely have a mass. But the 3 masses do not uniquely correspond to the 3 flavours. See, I'm told you, all of this would become clear as I explain it.
As mud, Hobbit, as mud.
A neutrino created with a specific flavour is a specific mixture of all 3 mass states. So you thought you were going to get rum and raisin. Actually, no, it's salted caramel and it's mint at the same time.
Salted caramel and mint.
Oh, no.
And rum and raisin.
Butter as well.
Oh.
And Neapolitan. And also it's got mango in there. I quite like mango, but not with chocolate. No. Also, it's chocolate. But it's cookies and cream chocolate.
What happened to Neapolitan ice cream? Do you remember it used to come in the stripes?
Yeah. So that is So you see, what they refer to this Ben and Jerry smorgasbord is a quantum superposition. So that's their get out of jail free. You see, it's everything and it's nothing at the same time, but it's totally real. Please keep giving us money. So this is similar to some other neutral particles. Neutrinos oscillate between different flavors.
What are the ones they're firing back in time? Is that neutrinos or is that photons that they're firing back?
I think they're tachyons, because
tachyons, that's it.
Tachyons go faster than light.
Supposedly.
Well, yeah. Because they have negative mass. So because they got negative mass, they can't go slower than the speed of light. But anyway, moving on. So you see, for example, an electron neutrino produced in beta decay reaction may interact in the distinct detector as a muon or tau neutrino. See, I told you this was simple. So beta decay, for all those paying attention, it's when you get a radioactively unstable substance and it gives off high energy electrons.
Listen to this because I will be asking questions.
There will be a quiz at the end of this, guys.
Yeah.
So pay attention. Make notes in your copybook.
Yeah.
So yes, as we know, beta decay gives off high energy electrons, which sometimes are positrons, but most of the time they're electrons. Occasionally they're not. They're electron neutrinos. Very fun thing is beta radiation. Now, so we said, but it may interact in a distant detector as a muon or tau neutrino. Why? Nobody knows. But there are citations here. Number 7 says, Grossman, Yuval, Lipkin, and Harry J., 1997, flavor oscillations from spatially localized source, a simple general treatment. And that's Physical Review, volume 55. And footnote 8, Belenki, Samuel M., 2016, neutrino oscillations from a historical perspective to the present status. And that's in Nuclear Physics B, volume 908. The free mass values are not yet known as of 2022, but they're really real, and they could be zero, we're not sure.
Moving on.
But laboratory experiments and cosmological observations have determined the differences of their squares. Yeah, an upper limit on this sum, which is less than 2.14 times 10 to the minus 37 kilograms, and an upper limit on the mass of the electron neutrino. See, I told you, this all will become clear. Very good questions in the back class, but do pay attention, please. For each neutrino, there also exists a corresponding antiparticle called an antineutrino, which also has the spin of 1.5, and no electric charge.
Is that your dad's sister?
Sorry, a spin of 1/2, not 1.5.
I said, is that your dad's sister? The anti?
Yes.
The anti-neutrino.
My anti-neutrino, yes.
Yeah.
And no electric charge. Antineutrinos are distinguished from neutrinos by having opposite sign lepton number and weak isospin. So they're not the ice creams, they're the sorbets. And
the palate cleanser for you having your next course.
I would really like a
How
peach
do they know it
sorbet.
spins? What are we on about spinning for now?
A peach or... Oh, well, you know, half spins are important. As opposed to full spins.
Why? I have so many questions.
Well, that's a very good question. But anyway, moving on. Antineutrinos are distinguished from neutrinos by having opposite sign lepton number and weak isospin. And right-handed instead of left-handed chirality. Oh,
spin is a legacy of classical mechanics, apparently, lads.
They have right and left hands?
Physics. Oh, thank you, Maximilian Spurg. Yes, this is... I'm glad we're clearing up the matter here, you see. It's quantum spin. It's like normal spin, except it's not. And spin is the wrong thing.
It's like normal spin, and it may or may not happen.
Yes.
It may not be spinning at all. Right.
So to conserve total lepton number, as in nuclear beta decay, electron neutrinos only appear together with positrons, which are the anti-electrons, or electron antineutrinos, whereas electron antineutrinos only appear with electrons and electron neutrinos, unless it's the fourth Sunday in that week, in which case they come as much better. Neutrinos are created by various radioactive decays. The following list is not exhaustive, but includes some of those processes. So, beta decay of atomic nuclei or hadrons. What's a hadron, I hear you ask? Well, that's a very good question. You can ask the guys at the LHC and they'll give you a real answer. Natural nuclear reactions, such as those that take place at the core of a star, artificial nuclear reactions in nuclear reactors, nuclear bombs, or particle accelerators.
Wait, artificial reactions in nuclear reactors? What does that mean?
When you see...
are they not just reactions in a nuclear reactor, not artificial ones?
The artificial nuclear reactions, because
they're quantum, aren't they quantum reactions?
Well, the reactions are produced artificially, because normally these reactions wouldn't happen, but because you're putting them in an artificed machine,
I know
now
that.
It's an artificial reaction.
But it's just a reaction.
You see, plutonium... No, I can't remember the one that exists. Well, yeah, okay.
Yeah,
plutonium does not normally...
238, uranium-230 something, isn't it?
Yeah, uranium-235...
231.
Well, uranium-235 does occur in nature, but in very small amounts, and that's why they have uranium enriching. But when you get like
was that the stuff they found somewhere? And it couldn't possibly have been real? They found a load of uranium somewhere. A type of uranium that can only be... Is it only enriched or refined or whatever?
Oh, yeah, except, like uranium byproducts and stuff, which could only be produced as the result of nuclear fission, which... Yeah. Definitely doesn't exist in nature, and we haven't had nuclear reactors in the past. So anyway, we did that one, didn't we? We got a list of places where you can find neutrinos. You can find them in the back of your sofa, sometimes in Waitrose.
Under the fridge, always go under the fridge, don't they?
In the dust around.
Spoons, they're just called dreams.
Lost property, King's Cross Station.
The lost and found at CERN. The majority of neutrinos which are detected about the Earth.
How about during a totally normal tunnel dedication in Switzerland?
Yeah, they'll sprinkle some neutrinos around just to keep the air, magical. The majority of neutrinos which are detected about the Earth are from nuclear reactions inside the Sun. At the surface of the Earth, the flux is about 65 billion, or 6.5 times 10 to the 10 solar neutrinos per second per square centimetre. Neutrinos can be used for tomography to the interior of the Earth. Oh, well, that's useful.
Oh, yeah.
So, neutrinos go into the Earth.
What's
you can do some
tomography?
Tomography is the thing where you're scanning, like, stuff. So, scanning tomography, like, they use it in medical science, like...
so, would you bombard it with neutrinos and get your picture that way? Is that what you're saying?
Yes.
Well, the neutrinos are being bombarded into the Earth anyway, and if you've got like a byproduct of neutrino...
Oh, so they're being bombarded in, so you then scan the neutrinos.
What you're scanning is the stuff which interacts with the neutrinos, which happens very rarely. It's only gravity and weak interaction forces, but occasionally, like something hits like a nucleus of an atom. Like in the case of a hydrogen thing, the proton, because that's the nucleus of a hydrogen atom. And then when that happens, you can see... No! This is where I told you to pay attention, class. What are the byproducts of a neutrino interacting with a proton?
10% off.
Burns in the back. Stop sleeping. I'll throw the board at you.
So I'm just drawing a unicorn in my book.
Well, now we know unicorns aren't real. We did an entire semester on that last term. So the collision creates a pi meson. But Black Forest Gatto, that's something I haven't seen in Aldi in a while. But Aldi are German. Why don't they do Black Forest Gatto? Yeah.
I'm going to start a school. I'm going to teach things that aren't real at this school.
Yes.
And I'm just going to have everything that we already have now. And
it's very important to teach the children. It's important that rather than learning reading, writing, and arithmetic, they learn about things which aren't real.
Yes.
Just in case they think it's real, and you need to disabuse them of that notion.
Yeah.
The majority need to... Oh, yeah, we said that bit. And then there's a history of them. Paulie's proposal. Hey, what if we hey, I got this idea to make money. I'm going to tell them about neutrinos.
Oh, U235 is the fissile one, Hobbit.
Yeah, I know. Hey, Paulie, what do you mean?
Neutron and positron, Maximilian says.
Paulie, what do you mean about neutrinos? Hey, forget about it. So they did.
all I'm saying, Tony, if they was real, why can't we see them?
And then Fred Rines and Clyde Cohen conducting the neutrino experiment.
Oh, sounds like a trustworthy fella, Clyde Cohen does.
Yeah, and neutrino flavour. They immediately decided, look, we can't just market it with just like neutrinos. Come on, we've got to compete with Coca-Cola here. What have you got? Well, we got Tutti Frutti,
cherry neutrinos, cherry flavoured neutrinos, and
cinnamon twist.
Yeah,
I quite like cinnamon flavoured sweets. There's a solar neutrino problem. The sun keeps like littering the solar system with neutrinos. In the 1960s. They're now famous. Who hasn't heard of the homestake experiment? Come on, hands up who hasn't heard of the homestake experiment. Right, hands down. I told you, unicorns aren't real. The homestake experiment, for you thickos who keep forgetting it.
Yeah.
It was an experiment headed by astrophysicists Raymond Davis Jr. and John L. Bacall in the late 1960s. Its purpose was to collect and count neutrinos emitted by nuclear fusion taking place in the sun. There we go. See? Simple. Right.
Yeah,
now,
simples.
The thing is, like, you know when they make you pay like hundreds of thousands of pounds to learn this stuff in university? Is it because, you know, if you actually like got a taster for this before you paid up your money, you wouldn't pay it?
It's like Scientology, isn't it?
Trap you in it.
It's like Scientology. Yeah. They don't tell you the bonkers stuff until you chucked about 200 grand in, and you got no house, and your credit cards are maxed out.
Exactly.
If I was to be cynical, I would say
sunken cost fallacy.
Exactly. That's it.
Basically, Scientology is sunken cost fallacy. You can't go back on it. Yeah.
So is science, by the sounds of it. Yeah, you've sunk 10 years of your life in, and then you start, you know, having a midlife crisis and thinking, "What the fuck have I done with my life?"
Here I am. I'm 30 grand in debt, and I'm gonna have to do articles about fucking wine for the Daily Mail every week.
Maximilian Spurg says, I do remember an old teacher saying to bear in mind this is all just a theoretical model. Yes. No. In the Freemasonic societies, they have degrees which you ascend up. But in order to ascend up the degrees, you've got to pay your dues. That's the DUES. You've got to pay your dues. Yeah. Now, if you pay your dues and you invest enough into your fraternal lodge, you'll be offered the chance to advance through the ranks, provided that you show adequate loyalty and profess to do
Donald Trump did
right
that,
things.
And he's still in trouble all the time with the law.
Yeah. So now, eventually, you get to a point where they're like, you start to see a return in your investment.
Yeah.
And put it this way, if you're ranks 1 to 3 in the Masonic lodges, you ain't getting a return on your investment. You've just paid like a lot of money for your exclusive like golf club, except you don't even go golfing.
Yeah.
So well done.
You have to have one trouser leg rolled up, don't you?
But the widow's sons, which are ranks 4 to 33 and above, those ones, you know, they get their dues and they collect their dues, and they do benefit from it. So it
must be demoralising to like go into one of these Masonic lodges and be, you know, going up for a sit and believing it, and then being told at the very end, yeah, we're just joking. That's a load of bullshit.
Like, that's not what happens at the end of Freemasonry. At the end of Freemason, they go, you've just sold your soul to the devil.
Yeah, and everything we told you was a load of bullshit.
Yeah.
Hail Lucifer, that'll be another £15,000, please.
Yeah.
Now, you see, with science, you could argue you've spent all this time, you've invested in it, there's this prestige, there's the thing of like, well, I've got my degree in science, my degree in science. I can't just be like, yeah, this is a load of bullshit. I'm going to become a lorry driver now. I'm going to give up this life of academia and get consternation from my family because it's like, well, you're so smart. Why are you wasting your time driving lorries about? The hypothetical person. Now,
it's a true story.
Because I'm smart, that's why I'm doing it.
Because you start to realise, like, the actual smart bit in science is, hey, look, I just got £5 million to research sharks. I just spend all the time, I go to the aquarium all day long and I get paid for it. It's like, the ice creams are on me. I've got £5 million in grant money. Would you like some photographs?
I literally get paid to put electrodes up a shark's arse. Yay!
Yeah.
Would you like photographs?
Are you proud of me, Dad? Are you proud of me, Mum?
Umpteenth time. Look, Dad, look! I'm jumping off the horse. I mean, shark. Tom Green, stop doing shark science.
You can imagine it. You can imagine it Christmas Day, can't you? Like, how's your little shark experiment going? Did you prove if they dream? Well, not really. We can't even tell if they sleep.
Well, you know what? At least you tried, and there you've got an ology. You can't. I mean, that is the definition of functionally retarded.
Yeah.
You've managed to con them for £5 million, and now you're going.
Have you proved your neutrinos?
Yeah, but it's functionally it's functionally proving who's retarded though. I bet that's the question.
Yeah.
Wow, it's brilliant, isn't it? It's like
do they need to do a follow-up one, which is who is the most retarded in this experiment, the person paying for it or the person doing it?
You know, Idiocracy, they were quite optimistic, right? Because they said...
Yeah, they were. Recently, actually, I was like, holy shit, this is not as bad as it's gotten. Fucking hell.
Do you want to know a bit of trivia about it? Have you noticed all the shoes they're wearing are Crocs?
Oh, yeah.
So, in the set design, the budget was limited, of course.
Yeah,
so, the set and costume design was told, like, right, you need to use something that looks futuristic, which people in the future will wear, but also looks totally retarded. And so there was this small startup company at the time called Crocs, and so they just bought a bunch of these Crocs. And then there's like, but what if they hit big? And then the set designer said, come on, mate, look, this is ridiculous. Who the hell would wear these on their shoes? Who would go to Buttfuckers restaurant? Formerly Fuddruckers. So yeah, in Idiocracy, all the top scientists in the world, rather than working on the problem of everyone getting more and more dumb, unfortunately, the top scientists at the time were interested in boner pills and hair loss serums.
You know what the most apt thing about that film was? It was the couple at the beginning who were like, "Oh, we're too smart for this. Like, we're not having kids." And there's the guy who's got like 20 million of them. He's an idiot. It's like, yeah, that's actually happening. That might be a problem.
Yeah.
By the time the dumb fuck family are becoming a granddad, they're just about to try for their first child, but it's like, oh well, my eggs are all rotten now, so we're going to try IVF. So it's like, oh, well done, you've saved up all that money working in careers. Now give it all to the IVF doctors.
Yeah.
Thank you. That'll be $90,000 plus tip, please. Thank you.
I said it's not quite that expensive. But
I don't care. Just give them all your fucking money.
Pretty much. Yeah. I mean,
because
you got to go through it, probably. Yeah.
Look, my Aston Martins and Jags don't pay for themselves. So fuck you, 45-year-old hag. Give me all the money, and then you can have octuplets, because IVF babies are often twins.
Imagine getting paid for putting someone else's sperm in another person's body.
Yeah.
Imagine that.
Normally that's a criminal offence.
I know.
So anyway, now famous homestake experiment. Yeah, influx of neutrinos arriving illegally across the border of our magnetosphere from the sun.
Yeah.
You know, coming over here and raping all our protons and making all these.
Greta Thunberg is Greta Thunberg not on the not taking the neutrino pill yet? Then.
Yeah, making all these half-caste bastard pie mesons, which are playing their bloody drill music at 3 in the morning, eating kebabs. It's ridiculous. So anyway, Stanislav Mikhaev noticed that flavour oscillations can be modified when neutrinos propagate through matter. The so-called Mikhaev-Simonov-Wolfenstein effect, the MSW effect, is important to understand because...
Could it be that he saw it go in, but another one came out and he got it wrong?
That's a very good question, and there's no citations here, so we'll just move on. Now, can be modified when neutrinos propagate through matter. They're so good. Yeah, we said that, but so it's important to understand because many neutrinos emitted by fusion in the sun pass through the dense matter in the solar core, where essentially all solar fusion takes place on the way to detectors on Earth. There's no citations for this. There's just like, well, that's where the fusion takes place in the sun, right? We definitely understand how the sun works. I mean, the sun's definitely a ball of nuclear fusion.
Yeah.
And it's not, in fact,
hot, therefore nuclear action.
Yeah, and it's definitely not just like some toroidal. It's not some sort of toroidal nexus of solar energy, which is a reflection of ourselves because as above, so below.
Oh, I did watch the Rick and Morty episode. You know the one where Morty has to become a Knight of the Sun.
Knight of the Sun.
And that was quite funny. He had to cut his penis off and throw it into the sun, Hobbit.
Oh God. I haven't watched stuff after the one where he like is a pickle and then
Rick.
he fights a cockroach.
I kind of noped out after that pickle.
There's some good stuff after that. It's not all bad after that.
Szechuan sauce thing, which is like, mate, how hard is it? Basically, to make Szechuan sauce, what you get is a whole bunch of high fructose corn syrup, Szechuan pepper, and a bit of vinegar. Right, now you've made Szechuan sauce.
Oh,
great.
That sounds really difficult.
Yeah, it is.
Oh, you forgot MSG, Hobbit.
Remember when there were riots about that?
It's Chinese cooking, so it's got to be MSG in there as well.
I don't know how McDonald's do it. I'm just assuming they use high fructose corn syrup, Szechuan, and yeah, they probably do use salt, don't they?
Yeah.
I don't think the Szechuan salt does contain. I don't know, but I really want some peach sorbet right now. Neutrinos have a half-integer spin, therefore they're fermions. Now, let's go into spin. Spin is an intrinsic form of angular momentum carried by elementary particles, and thus by composite particles such as hadrons, atomic nuclei, and atoms. Spin is one of the two types of angular momentum in quantum mechanics, the other being orbital angular momentum, so I'm glad we solved that. The orbital angular momentum operator is the quantum mechanical counterpart to the classical angular momentum of orbital revolution, and appears when there is a periodic structure to the wave function at an angle varies for photon spinners. These words are English, aren't they?
Fairly.
Because it's like
it's word salad. That's what they are. It's just fucking word salad.
You ever heard that one about definition of a lecture? It's about getting the notes from the lecturer's pad to the student's pad without passing through the brains of either.
Yes. It's now you may ask, like Hobbit, are you just filling in air on the? Are you just filling up space on the air?
We would never do that.
Well,
that's a very good question, but moving on to why we're talking about neutrinos, you see, because I wanted to explain this. There is a lot of bullshit science.
Because we love fucking science, don't we, Hobbit?
Mm-hmm.
Fucking love science. It's great. Science is brilliant. And what I really like about science is that there's no obfuscation of the truth of ether or other theories. And because of that,
you know, all the theories are there. They're out on the table. And what we need to do is what scientists do is the old theories, you know, because the old theories have been there a while, they need taking down, they need checking out, and they need to make sure whether they're still valid or not, don't they? And that's how scientists work.
It's brilliant. I really love.
There's no one there saying, no, you can't do that. Why are you an idiot? What, you think the Earth doesn't move? Are you a fucking
idiot? Science is completely 100% transparent. It's an open and democratic process. And the way we know this, right, is because the research grants for conducting ether studies are currently at $0.00.
Yeah.
And the research
there's definitely 0 cents.
Yeah, and the research grants for neutrinos are billion and 99 cents. So that's the open and democratic process, you see. There's research for boner pills and hair loss serums. There's not research grants for...
Red wine. Don't forget the red wine studies. Well, what would science be? What would science be without daily red wine studies?
The red wine studies are very important. Now, you see, red wine also exists in the quantum superposition, where it's either very bad or it's also very good for you, depending on who's writing the column for the Daily Mail at the time.
Well, it depends who's paying the scientist, doesn't it?
Yes, bacon's good for you, but bacon's bad for you. But if you have bacon with red wine, it's okay.
Yeah. Oh, no, but you can't have bacon with red wine because that's bad. Oh, bit mate.
Hello?
He's still there. Well, where's he gone?
I don't know.
What?
Disappeared.
Me?
Well, you just saying something, then you disappeared. Thought you'd fell down a manhole or something.
No, I
fell into a neutrino mass. You know,
I was sitting
you've
up.
Been peppered with neutrinos, I bet.
My throat's been peppered with something. I really want to drink.
Yeah. Well, it's nearly 9 o'clock. We done?
Yeah. I think you get the point. Is that
science is ace. Science is ace.
Amazing.
Science is brilliant, and it's always double, triple checked, and it's always absolutely correct.
Indeed. Scientists don't have an ego. Scientists can't say they're wrong.
And neutrinos aren't pubes.
Everything's on the table with science.
Yeah.
Just not certain subjects, like ghosts or if the Earth is spinning or not, I guess.
Alright, so it's 9 o'clock. It's 90 night time.
Night, boys. Bye.
Say goodbye.
Go away.
That's it with them.